All right, welcome back. In this video around the environments, we're going to talk a little bit about water and specifically look at water performance and aesthetics and try to understand a little bit about which direction we should go in our program. And so what I've done is created these 4 different water volumes that you see here in the screen. And I've gone ahead and just captured some of the material information. So they're all identical water bodies. The only thing different in all 4 of them is the surface material. And of the 4 surface materials, what we will refer to as number 1. Here are the statistics around number 1 from the material editor. For number 2, these are the statistics around number 2, and for 3 and for 4. And so we're looking at anywhere from 460 instructions through 316 to 287. We've got texture sampling anywhere from 14 to 9 to 5 and 4. And then a variety of other things such as lookups, adds, subtracts, divides, etc. So these are the 4 materials that we're going to look at. And so let's jump into the editor. So here in the test level, we set up the 4 materials for the water shading in 4 water plugin lake bodies. So the actual water bodies are identical. They're all based on the plugin water volume. They all have the exact same post-processing setup. The only difference is the material that is used for the surface of the water. And you can see here the 4 representative water materials that we just showed the statistics on. And we've placed pylons in each of the water bodies so that we can keep them straight. So this is the water body for the statistics on number 1. This is the water body for the statistics on number 2, number 3, and number 4. And in addition, as notated, this is the basic plugin mask single layer water. So this particular water body is what the plugin provides as a startup piece of material. That's this one. Then we have this one over here, which is pre-plugin, something we would have done all the time, which is a translucent one-sided material. And you can see here that we've got some stylized effects going around the mesh, and we've got some sparkles or foam in the water and some wave action in the water. So this is our translucent. This one is also translucent one side. This one has similar effects to it in that we have the shoreline effect. This time we have some ripples. We don't have the sparkles, and it's using the same translucent one-sided. And then this one is a translucent two-sided effect. And it is another example of using a water. The interesting thing is, in fact, the two-sided did not cause this one to be more, well, it does cause it to be more complex, but it's not the driving factor. If we switch over to look at our optimization views and our shader complexity, an interesting occurs. So as I look at these 4 with shader complexity, the plugin water volume is all green. It has the least amount of complexity. The number 2 has a sort of dark red. 3 becomes pink, and 4 is way over here in the highly complex. And what I thought was interesting was even when I turned off two-sided, this still remained in the full white, all complex. So what's important here is, though, even though we had the statistical counts a few minutes ago and it showed you how many samples and functions were being used in each of those graphs, they didn't necessarily translate into where they stood in shader complexity. The other thing that's also interesting is if you look at the actual nodes, So if I look at this node, the number 2 node, and the number 3 node, number 3 being the more complicated shader reference. If I look at this graph compared to this graph is actually the one that's more performant. So this graph is this one, and you can see you having better overall shader performance, even though the graph itself is significantly more complex than this other graph. This is the one where, again, we have fewer instructions. So if I compare the two of these, right, 287, so the same number of things. The big difference I've noticed is that the texture sampling is 9, whereas in this one, the texture sampling is 5. So texture sampling could be a good indicator of how well it's going to perform. However, the true test is to go in-game, bring up your shader complexity, and have a look. So based on that, we're going to base our water on this plugin, which is the single layer water. So we're going to spend a little more time on the single layer water because it was newly introduced with the plugin, and it clearly performs better than any of our translucent materials. And so what we're going to do from here is work with the single layer and try to create these stylized effects to the best of our ability in a single layer volume so that we get performance. And as we just concluded with our own tests, if we go through the documentation around the single layer water material, you'll see 2 notes somewhat down near the bottom of the page. One indicating that while you can use any shader model you want with the water bodies, so you can use the translucent, which we did. It does say down here that a single layer water shading model provides translucent and lighting results at a lower cost than a traditional translucent material. So that is exactly what we saw on our tests, which is why we're going to go forward with the single layer water shading model. So now that we've decided that the single layer water volume material is going to be our base material, then what I wanted to do was copy each of the material elements into our own folder so that we don't edit the plugin content, but basically clone it all and hook it up. And so if you drag in the lake or the ocean volume and navigate, it will take you, this is just a shortcut to take you down into engine, content, water content, and then in these subfolders in water content, you will find the materials folder. And in the materials folder, you'll find the water surfaces folder. And here you find a variety of materials and material instances. So the main material, water material, is where most of the function logic is. So I've copied that over. So basically, you're going to copy the bar mesh material instance, the water material, the material instance, if you need that, the lake, the ocean, and I didn't bother with the river. And then I also copied the LOD for the ocean, although I'm not 100% sure that was necessary. So I basically made copies of the various materials, and then I renamed them so I wouldn't get confused. So I have my M water base, which is the base material function from the plugin, my material instance for water far mesh, my lake water, my ocean water, and my LOD. And then by going into each of the material instances, you go down to the bottom and I changed its parents to be back to water-based. So each of these have been reparented back to my water base, which was a clone of the original material. So this is kind of the original material. And I have made some changes in here, but essentially this is what it'll look like when you copy it over. And then in your level, you'll have your lake. And in the lake, you set, all the way down here, you set your water material here. This is the surface water material. I have not changed any of the underwater post-processing volume. I did set these, but I don't think they're needed. But anyway, this is the one that you really need to change. On the water body ocean, same thing. You scroll down and you change the water material to your own water material. So that changes the basic water surface here, as well as out here. The odd one is way off in the distance. So after the dynamic water ends right here, you pick up this static mesh that is drawn to the extent of the world. And this is actually found not in the ocean where I thought it might be originally, but in the water zone. So in the water zone, you go to details, to the water mesh. And you replace it right here. The far distance material is right here. So that should give you at least the 3 places you need: the base, the instance for the lake, the instance for the ocean, which is on this side of the line, and the far mesh, which is on this side of the line. So you'll see here you have this line where the moving ocean meets the more performant still ocean, and you want those to kind of color match. Now, there was another thing that I noticed that when I first did this, if I stood back on the island and I looked out to the horizon, depending on how high you got into this, you could really see the harsh lines of the step-offs. And what I found important to do is to extend my landscape further than I originally had my landscape ending right along this line. So I went into landscape, manage, and resize, and I expanded the landscape further out. And if I turn off the ocean, you'll see that I applied some variability to this landscape, the bottom of the ocean, for a fair amount of distance off of the island. And then I sort of made a cliff by sculpting the edges of these down. So I basically sculpted and held down shift to lower these points. And then I used some noise to introduce some noise into these areas so it's not all flat surface. And the reason that's important is if you shut your landscape off kind of the edge of your water, you get this double impact where not only does the water transition from this sort of light blue translucent material to this darker blue kind of very harshly right here on the line. So this allows the further extension of sort of the ledge, and then pushes that transition period further out into it. So while this is the end of the dynamic water, the static water allows that landscape to be seen and then eventually transitions to dark blue. So that when I am this far back, you get a better effect on the ocean to see kind of an inconsistent drop off of that ledge. So let's go down here and hit play. And you'll see the changing of, I've got the light changing to get different reflections on the water to see that the shadow is moving around that column. If I go to the ocean, I put these rocks in here to watch how that shadow might creep along the floor of the water. And then if you look into the distance, you'll see the sort of more seamless blending of the moving ocean with the still ocean. You still kind of see the line there, but it's better than the harsh line that was originally in there. And then of course at nighttime, there's not as much light, so your water becomes much darker. Because of the absorption properties, we don't have the light. And then as the sun rises between those two trees, which I've got the day cycle set to about every 70 seconds. So here, as it becomes daylight, the water starts to become more translucent as more light is coming off and the water shifts. So let's take a look at the material, and I'll try to focus on the elements that are different from the standard water shader. So let's go into the base. And the first thing I did is, if you go to the beginning of this line, all the way back here, you should see water attributes as your first node. And water attributes is what feeds the base colors into the start of the water. I went ahead and copied that and called it stylized water attributes. So I have a function that is was a copy of the original water attributes. I called it stylized. I pass in two parameters for the shoreline masking and the sparkles in the water that you saw on the lake. And if we open this up, much of this is consistent. This is consistent, the surface color. I did not change that. It used to be called albedo, but I just prefer to call it surface color. I added this logic here. And basically what it is, I created two functions, the shoreline function and the sparks, just to compartmentalize those logic. I used some static switches and some input nodes. So these static bool inputs, they have to be static, and the default value is true. Allow these static switches to either add or remove these chunks of code in the material instance. So I take the resulting material and run it through the add shoreline, and then run it through the add sparks, and then that material comes back out into water base right here. I'll go into those functions in a moment. The first line is the shoreline, this one that's moving with the edge of the water. The foam is this line that is sort of moving away from the shoreline. So that first function basically creates this opacity mask and this moving opacity mask that kind of rolls off of the foam. So those are the two things that the shoreline function is doing. Next, if we wanted to add sparkles, we take that material out of the shoreline and into the sparks. So we've basically started with this standard function. We added the shoreline and the sparks, and that's what comes out of our stylized water attributes. So coming out of this function, we have the surface material. Then here, that flat surface material is added with normal maps and waves. So here's where the wave generation occurs. So we're using the basic wave generation that's happening in the material. I didn't change any of that. That is consistent. The normal maps is consistent. So those get applied here. And then there are a couple of switches for whether or not to enable river foam, beach foam, which I do not do in my lake, and fluid simulation. And that basically eventually runs out to your water base. Oh, ignore that. I was just testing. And so that does the surface material. At the same time, you'll scroll down here and you'll see the simple layer water material, which has 4 inputs. The easiest is this phase G, which just is a constant. That's unchanged. The color scale, where basically the only difference is I replaced the water attribute here with the stylized water attribute to make sure they're consistent. And for generating these caustics, I just put false in because I don't need the sparkles in the shoreline for that. So that saves a little bit of performance. And then we basically do the refraction of the Gershner waves and include that in the material. For scattering and absorption, which is where most of your tweaking is going to occur. For scattering, I believe I changed the scattering color. The original scattering color was, I think, more white. I think I changed the scattering adjustment. But the rest of this, because we're not using ocean foam, I didn't bother with. That goes into these 2 masks, which fundamentally doesn't change anything, and then into the scattering pin. For absorption, I played with a lot of different formulas that I felt were overly complicated, weren't giving me the effect I wanted. What I did come up with is, if you read any of the documentation on absorption, you want to specify the colors that you want to be absorbed by the water, which I found a little bit difficult to mentally process. What I chose to do was have the watercolor that I want to target, and if you do a 1-, it will remove, or it'll flip this to its negative, which is what you actually want to fill into your absorption parameters. So I basically said, look, if I want this water to be, completely blue, then I need to pull out all of the yellow. Since I want it to be blue-green, it'll pull out, this will evaluate to red. Not sure why it didn't refresh. We'll evaluate to red. And so as you adjust your target values, this 1- will automatically compute what colors need to be absorbed to achieve this goal. So that's just a little easier way than having to define the opposite color. Then I have a murkiness factor, which is multiplying by 1 right now. So that I can play with that in the parameters, and then divide by 100, and then a saturate, and that goes into absorption. I also have an absorption intensity that I can kick it up after all these masks, and then of course I saturate to clamp it between 0 and 1. So this is the area where you will play the most in to get your watercolor the way you want it. From there, it's simply a matter of looking at the water and pulling up your material instance. Now, what I do like to do is when I get to this stage and I have a material that I like, which is this lake, I'll create an instance off the instance, and let's call this test. Change my lake to that new test. lake selected? I do not have the lake selected. Make this the lake test one. Interesting. Now that's interesting. While building out the stylized water, I noticed this other anomaly that I thought I would point out in case it's happening to you as you're doing the same. So I felt I was getting my water pretty much where I wanted it. I was liking the consistency and the look of the water in the editor. However, when I went to play, the water comes out much murkier. And so I'm not really sure why playing in editor, it looks a lot murkier than editor like this. But again, something that I will be digging into. And as I discover what the root cause is, we'll add to the description. Okay, we'll keep going. And I can now play around with this one until I get the visuals that I'm happy with without destroying the other one. Because what happens is if you start playing around with a bunch of parameters, it's hard to remember what you originally had before that. So, for example, in my water absorption, if I want to decrease the green and give it a bit more of a blue look, I can do that. If I want to look at my foam lines, so let's go over here where we have some foam lines, and I have 2.5 lines and their thickness and their speed. So let's double the speed and let's go to 4.5 foam lines. So you see we have more lines, and let's make them minus 0.25. So they're a bit thicker. And let's allow it to go 90 away from the surface. So I've changed these foam lines and I've changed the color of the water. And let's take our murkiness factor down so we're less murky. And then basically if this is what I like, then I can just do show override parameters. These are the only ones that I've changed. I could now write those on a piece of paper and go over to my proper lake water and copy them over. Or if after all that experimentation, I still like my original better, then all I have to do is go in all I have to do is go back in here and take it off my test back onto my lake, and I'm back to my original settings. So by creating another instance just for tweaking, it allows you to maintain and keep your previous version. I just find it easier that way. All right, so we have our water volume here. It's starting to look quite stylized. Here we see our sparks. Here we see our ripples. Sorry, our shoreline and our foam. And so now it's a matter of just kind of testing it out from a variety of locations, making sure that things look good. I did notice that on the lake volume, so if we go to our waves, which are up here, the wave attuning water depth, the higher you set the number, the stiller the lake will be. So I have this set at 6,000. If I take that down to 1024, you'll see a lot more motion in the water. And so 512, even more motion. I felt like about 6,000 depth gives me enough movement in the water without too much movement that it looks unrealistic. So then the only thing to do is sort of check your final configurations in your day-night cycle so that you see your water casting around. The other thing is I have a climate volume over here now. So as I climb these rocks, you'll see them getting wetter. So they're getting shinier because they're getting wet. The rain gets heavier as we go up the mountain. And as the sun sets, you see the green. Didn't get up here fast enough. As the sun sets, you saw the little green line appearing in the water as the sun went down. And now we're into a dark and rainy, foggy environment. So we're going to talk a little bit about a problem that's happening in the Lyra project that I don't quite know how to correct yet. When I do find it, I will leave a comment in the description and what the fix is. But as you can see on screen, I'm getting my shoreline effect around the static mesh, but not around the landscape. So there's no shoreline occurring around this landscape. And I was able to track the issue through looking at two different things, two different project files, where it's not happening in another project file. So there's likely a setting difference between Lyra and when you start a brand new project fresh out of the editor. So if I go over to another project, and this is just a blank project template, I've created a basic landscape, did a little bit of sculpting. I haven't even put a material on it. It doesn't really matter. I brought in a static mesh. I'm going to copy that and scale it up. And what I've noticed is in this project, if I go to show visualizations, global distance field, this is what is being sampled to generate the shoreline. You'll see that the landscape and the meshes all show up in the visualization global distance field. However, if I go back into our Lyra project and do show global distance field, you get the meshes, but not the landscape. The landscape is absent from the scene. It's not showing where the landscape intersects, and therefore, when we attempt to draw our shoreline, that data is missing from this part of the shore, but it's present around each of the meshes. Even creating a new level, inside of Lyra, I have a blank level, sky atmosphere, directional light, landscape, make it smaller. Okay, so we have grass. Sculpt this up a little bit. Good. And go grab a static mesh. And you can see already it happened. As soon as I brought a static mesh in to the level, it starts to generate the distance mesh field. and none of the landscape is generating. It's all black. So there's some project setting in Lyra that is excluding the landscape from the mesh distance field. That doesn't happen in a brand new clean project. Brand new clean project, you get both the landscape and the meshes appearing in the global distance field, which of course is causing our problem of our shoreline not appearing in the Lyra game. So as soon as I have a solution for that, or I know what property setting that is, I will update the comments. Let's take a closer look at the shoreline function and walk that, which is creating this first band along here. So if we open the shoreline function, we'll start up here. What we're basically doing in the shoreline function is we're taking a material attribute into the function. We are getting its base color and opacity. We are adding in our base color and opacity for the shoreline, setting that material and passing it up. So this is us adding the shoreline into the material flow. So the only other things we need to do is calculate these two values, which here we add together our foam line. So important that the foam line and the shoreline. The foam line is these lines here. The shoreline is the line closest to the base. So these are the foam lines. We'll come back to that in a minute. Let's start with our shoreline. So this large block here defines our shoreline. And the important thing to note is we are taking two texture samples of this distortion noise texture. You can use any noise texture you want. But if I open that up and I am using the green channel, so if I look at simply the green channel, I'm sampling this noise to create my foam as opposed to just pure white. So basically, as I sample across here, we'll get a series of grayscale values. And I'm panning that in two different directions and scaling it two different ways. So I'm creating more noise by the distortion scale and the speed. And we basically run that through a panner and then sample the green. So we do that for both of those samples. Here we start with our absolute world position node. We get our distance to the nearest surface. This is using the mesh distance field. We're saying we only want 15 units off of that, and then we're going to cut it off. So we're dividing that by 15. We output that value because we need it for the next function. So we're simply outputting it here, doing a 1 minus to invert that number. Then we're taking our green sample and we're doubling it up and adding that in. We're taking the other sample and we're tripling that up and adding that in. And then we have a weighting factor, which allows us to play with the overall weighting. We saturate that to make sure we're between 0 and 1 because we could have got numbers greater than 1 by the time we did all that math. Anything greater than 1 comes back down to 1. And that feeds into our add for the shoreline. So basically randomize some noise, double this one up, triple this one up, add them all together, clamp them to 0 and 1, feed that into the add. You'll also see that we've got a couple of linkage points back up to our foam. So we take our same logic for our distance through the mesh distance field. We say we want the foam to go further. So we're allowing the foam to go further away from the rock than the shoreline. We invert that. We add some speed by using the time node. So we add some speed to that line, so how fast that line is going to move. Then all of this is about the actual number of lines and how thick the lines are. So we take our output from this texture sample, which gives us a bit of randomness. Found multiplying by 0.7 worked. Adding that in, take the other texture, multiply it by 1.5. So this is sampling the second texture. Adding that in, multiplying the result of that by how many lines I want. Feed that into a sine wave. This is what actually creates the wave. And then basically adding or removing some thickness of that resulting sine wave to make the lines thicker or thinner. And then we've clamped it at a random number off of this texture. So we took this texture, we shrunk it, and basically added that to the other texture and are using a clamp here. Because if we didn't clamp it like this, the final line doesn't fade out. See how this final line fades away? If we left that without being clamped, that final wave would be very solid like these ones are. So we want the last wave to fade away. And that's what this clamp is doing, is it's randomizing the point at which it goes away. And then we add that into our node, and that's it. So this logic is creating the shoreline effect. These nodes are creating the waves. The two of them are added together and inserted into the material. Now let's take a look at the sparks and exaggerate some of the values so you can see how that's functioning. So I've got my test material, and each white blob is a spark, and each area is a mask. So there are mask, 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 multiple sparks inside the mask. If I show you the whole, so I'm not reducing the spark zones at all. And let's take our mask zone in half, or I guess a tenth. You see that we have smaller mask zones. And then let's take a bunch of those away. And let's shrink our individual sparks for one of them. So you can see here, the underlying sparks are much smaller. The top sparks are much bigger. If we do the exact same, they both go down in size. We reduce the maximum amount of sparks. Take our mask back up to a bigger number. It's a little hard to see there, but you have sparks happening over here. That's because we've reduced the maximum amount. We bring them back in. You can see them navigating through. And if I want it to be much blobbier, go with 500, 600, or even to go even more nuts, 1,000, 1,000. So you can start to see that how by adjusting the mask size, the reduction, and the size of the individual sparks, which we did not play with, is really slow sparks, really fast sparks. So you can get a variety of different results by varying these parameters. And so let's go take a look at that material. So the add spark is just like the shoreline in that we take a material and we add the sparks back into the material flow. We have 3 large blocks of logic. This top one is the mask. This is the individual sparks, and this is the shoreline to mask out the shoreline. Basically, only sparks that are inside a mask will get shown. So let's look at the spark generation first, and you can see here in these nodes as I move around, you're getting to see how those sparks might manifest themselves. For the actual spark, we have our spark scales, our absolute world position, and our time, which allows us to divide time in half and then multiply it back up. So this is what allows us to vary the flow speed. We have 2 panners set in different directions. This is to enable these patterns to go in different directions. So one panner is going this way and another panner is going this way. So you see the difference in as these are going in different directions. So those panners are allowing those to pan. We're then sampling swirl noise texture. And based on the scale, we end up with a sample off of each of these, which we combine together and then saturate so that we end up with this as the resulting spark, which we mask away the shoreline. So we keep sparks from being generated in the shoreline through this multiply. And then that is combined here with the actual mask from above. So we have our spark generation being multiplied by our mask. And our mask follows a similar process where we scale up the actual mask. We use our world positions. We run it into 2 panners. Those panners are sampling the noise RGB sample, just so it's a different sample. We're taking the red channel out of each of those and we're adding those 2 channels together. So we end up with this additive mask here, which is where do both of them contribute to this final mask. That's not needed. Then we have our reducer, which will allow us to take away a portion of the mask. And then we do a final saturation to get the actual mask. So that's sort of how this whole thing flows together. That mask is multiplied in here. And then we increase the intensity with this final multiplier, which I did not show. So let's go here and take the intensity down to 1. You'll see that they're quite dull. And if you bump that intensity up, you'll see that they're very bright. So you can vary how intense they are by varying the intensity of the emissive. I like about 20. And there you go. So that is the sparks. So we've seen the shoreline, the sparks. We've talked through the use of the single layer water material, adjusting the absorption, the scattering, and the shoreline and sparks. Hopefully that gets you started on using water. Oh, the last thing we need to do is make sure that we haven't created an overly complex shader, and we're still green. So with all of that happening in that volume, we still have reasonable shader complexity, and that was the goal at the beginning of this video. So thanks for watching.